Today we will be learning how to simplify radicals. So let's start with one that you probably already know, the square root of 25. And yes, this one you would be able to just plug into your calculator and get the answer of 5. But since the ones we're going to be working with now are not perfect squares, let's figure out another way to figure it out so we can use it for all radicals. So if we have 25, what we're going to do is create a factor tree for all of these. And two numbers that multiply together to get 25 is 5 and 5. And you go all the way down until there's all prime numbers. But for this one, it happens that 5 and 5 are both prime numbers. And what you're going to do then is, since this is like a square root, and you don't need the 2 there, I'm just showing it, you pull out 2. So pretty much, it takes 2 to come out of square root jail. So the 5 and the 5 come out, go together, and just becomes a normal 5. So whatever pairs they are, they come out, and that now when you make it a 5, it jumps out of the square root, but you need pairs for that. So let's look at number 2, one that's not a perfect square. So if we have number 2, this is going to be the square root of 50. So what we're going to do is do a factor tree for 50, get it down to all prime numbers. So let's see, 5 times 10 equals 50. 5's a prime number, but 10's not. So what two numbers multiply together to be 10? Oh, well that's 2 and 5. And again, what happens is that you need 2 of the exact same number in order to pull it out, and so the numbers can get out of square root jail. So they need to go. So like 5 and 5, they're the same number, so they are able to go on a date. So the 5's come out of square root jail, but poor 2. 2 doesn't have a date. There's no other 2 to leave jail with, so poor 2 is stuck in square root jail. And 5 square root of 2 is your final answer. And let's look at another one then. So number 3, for instance, is the square root of 54. So we're going to do the factor tree of 54. And let's see, 54 can be broken down to 2 and 27. 2 is a prime number, but 27's not, so we have to go further. Well, 3 times 9 equals 27, but 9's not a prime number either, so we need to break it down further. 3 times 3 equals 9. And you can only circle pairs. So we have this pair of 3's, and even though there's another 3, you could, excuse me, only circle 2 3's at a time. So this pair of 3's can come out of square root jail, but there's no other pairs. There's just a 2. There's no other 2. There's one 3, but there's no other 3. These are already taken care of. So the 3 gets to come out of square root jail and go on a date, but 2 and 3 are stuck inside square root jail. And what you're going to do with the 2 and the 3 is that you multiply them together. So 2 times 3 is 6. So it's really 6 that's staying in the square root. So again, if you have more than one number that is not able to go on a date or come out of square root jail, you multiply those two numbers together. 2 times 3 is 6. So we have 3 square root of 6. And number 4, we'll have the square root of 192, just to see even more examples. So we have 192. That can break up into 2 and 96. Then we know it could break up into 3 and 32. But 32 is not a prime number, so we have to go further, like 2 and 16. 16 can be broken up into 4 and 4. 4 and 4 are not prime numbers, so we have 2, 2. 4 is 2 and 2. And finally, we have all prime numbers. We have the 2, 3, 2, 4, nope, no 4, sorry, 2, 2, 2, 2. And all of these numbers that are not prime numbers, make sure you do not take those into account. The ones that are broken up further, you don't look for pairs. Nothing. So we can't take those two 4s. Those don't count. It's only the prime numbers. So then we start circling the pairs. Oh, hey, these two 2s can go on a date. These two 2s can go on a date. And we actually have another pair of 2s that can go on a date and get out of square root jail. So we have actually 3 2s that will be coming out, but oh, poor 3. There's no other 3s to go on a date with, so it's stuck in square root jail. And just like how when there was 2 left in square root jail, you multiplied them together to get 6, however many 2s can come out, so this makes 1 2, 2 2s, and 3 2s, you multiply those together. So if in doubt today, multiply, whether it's the ones for inside square root or the ones that get to come outside the square root. So 2 times 2 times 2 is 8, and that poor 3 is still stuck in square root jail. On number 5, let's look at one where there's a number already out in front. So we have -5 square root of 300. Again, we start off with the factor tree for the 300. And I would probably break it up into 10 and 30, because 10 times 30 is 300. You can break it up any way you want. You could have done 3 and 100. But 10, okay, 2 times 5 is 10. Hey, 2 and 5 are prime numbers, so we can stop there. 3s can be broken down into 5 and 6. 5's a prime number, but 6 is not, so 2 times 3 equals 6. And again, don't take into account any of the numbers that are not prime. We're just looking at the prime ones. And we start circling pairs. So we have these 5s that can go on a date and get out of square root jail, and these 2s that can come out and go on a date. And remember, we said when we had the 2 and the 5 able to come out, you multiply them together. But up here we have that -5 out in front, and you know there's implied multiplication in between that number and the square root. So we have 2 times 5 is 10. So we still have that -5 out in front being multiplied. And let's see, was there anything? Oh, poor 3. 3 is going to be stuck in square root jail because, again, there was nobody that 3 could go on a date with. And this is not quite your final answer because you're going to multiply -5 times 10 to get -50. And you have -50 square root of 3. And that is going to be your final answer. So if there's a number out front, again, I told you the key word to get day was multiply. So if there's a number out front, whatever can come out of the square root, because they have dates, you multiply the number that was already out there with the one that's coming out to get -50 in this case. And let's just do one more to prove to you that 3 is not always the one that is stuck in square root jail. So we have the square root of 18. And we break down 18 into like 2 and 9 and 3 and 3. Oh, good. 3's not left out this time. 3's get to go on a date. And they come out of the square root. But poor 2 this time, there's no one to go on a date with, so he is just stuck in square root jail. And we have this answer as 3 square root of 2. This is simplifying radicals. To go to the next concept of multiplying radicals, please watch the next video.